Balloon 6-3 layout to launch. In the meticulous world of hot air ballooning, the choice of a launch site emerges as a critical decision, hinging on factors like obstacles in the flight path, power lines, buildings, towers, available landing sites, and the nature of the launch site surface. The location of the launch site is intricately tied to surface winds and winds aloft, aligning with the preferences of the balloon pilot. It's a delicate dance between the type of flight planned and the overarching goals of the journey. Upon arrival at the chosen site, a common practice among pilots involves releasing another pibble to validate the wind direction and ensure alignment with earlier forecasts or readings. Ideally, a capacious, open, grassy expanse constitutes an optimal launch site. The positioning of the balloon in relation to obstacles in the flight path demands strategic thinking, advocating for placement as far upwind as possible, granting at least 100 feet of clearance for each knot of wind. The effectiveness of a launch site hinges on its ability to provide not only a smooth ascent but also a clear path for the balloon to navigate. Yet, the best-laid plans are futile without due consideration for appropriate landing sites downwind. Pilots often adopt a reverse planning approach, evaluating potential landing areas, and tailoring their launch site choice accordingly, even if it means compromising on the ideal launch site. Safety and obstacle clearance take precedence in this decision-making process. The nature of the launch site surface serves as another crucial determinant, shaping the specifics of the balloon layout. While the dream scenario involves a clean, dry, short, green grassy terrain, the reality for most pilots involves adapting to varying conditions. Wise pilots flex their techniques based on the ground reality or maintain multiple layout procedures catering to diverse launch sites. Regardless of familiarity with the launch site, whether it's a regular location, a new spot, or a designated square at a rally, a thorough ground check is imperative. Nails, sharp rocks, twigs, branches, or any foreign objects must be identified and removed to prevent damage or soiling of the balloon. If oil patches or other substances are present, resourceful pilots cover them with materials like carpet scraps, floor mats, tarps, or even the envelope bag. Some pilots go a step further, covering the entire launch area with a large tarp before each flight. Driving the chase vehicle onto the launch area isn't a universal assumption, especially in sensitive locations like soft athletic fields where carrying the balloon onto the launch area may be necessary. When private property is involved, securing permission becomes paramount, introducing the pilot to the nuances of landowner relations, an aspect delved into later in this chapter. As the balloon sits patiently in the chase vehicle, the wind direction becomes a guiding factor even before it's unloaded. Cold inflation considerations are weighed against the surface wind, avoiding the cumbersome task of lugging around a hefty balloon bag and basket. A nod to Murphy's Law, a wind change is almost inevitable during inflation. Local insights become invaluable, and experienced pilots in the vicinity are consulted for their nuanced understanding of wind behavior. In the realm of hot air ballooning, where precision is paramount, launch site selection involves a delicate interplay of meteorological factors, practical considerations, and respect for the environment. Each decision, from the choice of a grassy expanse to the meticulous ground check, lays the foundation for a safe and seamless flight experience. As the launch field's specific spot is pinpointed, the delicate ballet of preparing the balloon for flight unfolds. Careful choreography at this stage minimizes the physical strain on the crew and the pilot while ensuring the equipment's longevity. Despite the balloon's ethereal nature, the packed components, basket and envelope, bear a substantial weight, often exceeding 550 pounds for an average sport balloon system. Efficiency dictates the procedure of unloading the basket and maneuvering the vehicle forward. This strategic approach not only eases the burden on the crew but also extends to the wear and tear on both human and equipment. The pilot, acting as the conductor of this symphony, designates the precise location for the basket and orchestrates its removal. The transport vehicle adjusts to facilitate the basket's placement at the pilot's discretion, subsequently moving forward to allow for the removal and positioning of the envelope bag and inflator fan on the ground. Once this balletic sequence concludes, the vehicle may exit the launch site or find a spot at the rear of the basket, ready to serve as a tie-off point for the balloon's quick-release system. This method not only streamlines the process of lifting and carrying heavy components but also lends itself seamlessly to the post-flight packing routine, ensuring readiness for future flights. Moving on to the assembly phase, if the basket had been disassembled for transport, meticulous adherence to the flight manual is imperative. The pilot, armed with the checklist, takes charge of these assembly tasks or oversees them with precision. The basket, having found its designated place, demands the attachment of uprights and, where applicable, the burner frame. Each balloon brand introduces subtle variations, necessitating a careful reference to the flight manual for specific procedures. Depending on the balloon type, some baskets may need to be placed on their side for upright and burner installation, while others can remain standing upright. Regardless of the method chosen, a diligent post-installation check follows, scrutinizing the components for proper installation, structural integrity, security, and overall condition. This meticulous attention to detail at the assembly stage lays the groundwork for a flight that prioritizes safety and optimal performance. In the intricate ballet of balloon preparation, the unloading and assembly processes are not mere logistical steps. They are a symphony of movements designed to harmonize efficiency, safety, and longevity. From orchestrating the removal of components to the meticulous assembly of the basket, every action is a note in the composition of a successful hot air balloon flight. Moving on to the burner and fuel system, if not previously accomplished, the burner or heater should now be mounted and connected. This involves securing retaining pins, if applicable, and connecting fuel lines between the burner and the tanks. However, it is advisable to refrain from using adjustable wrenches on fuel line fittings due to their tendency to cause excessive wear over time. Instead, using the correct size open-end wrench is recommended. Fittings don't require excessive torque. Finger-tight force is usually sufficient. Excessive force may indicate issues such as corrosion or a damaged flange seal in the fitting. At this stage, it becomes crucial to check for leaks in the fuel system as part of the checklist. The pilot opens the fuel tank valves and performs a sniff test to detect the distinctive odor of the propane's odorant, ethyl mercaptan. This check extends to each connection, both at the tank and the burner. The burner itself should be examined to ensure there are no fuel leaks from fittings, pressure gauges, or interior plumbing. Once it is verified that there are no leaks, the fuel can be turned off, and the pressure bled off, preparing the basket for the next function check. The burner check is a vital step, often mandated by manufacturers as part of an equipment function check. The procedure is model-specific and outlined in the flight manual for that particular balloon. Typically, each burner, including the pilot light, undergoes individual checks to ensure correct operation. In a scenario where there are multiple fuel tanks connected in parallel, each tank is opened sequentially, and the blast valve is activated to check for correct operation. This process is repeated for each tank, ensuring the smooth movement of the blast valve and checking for pressure in the fuel system. The backup systems are also tested for correct function and operation. Pilots should avoid the hazardous practice of opening all tanks in a parallel plumbed system simultaneously. It's noteworthy that some pilots opt for a burner check at the beginning of each flight, while others, especially during events like balloon rallies, may conduct a full burner check for the first flight only, subsequently checking for leaks in the remaining flights. However, this practice may violate the manufacturer's operations manual and is generally discouraged to avoid potential issues.